Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Okay, today we are looking at this question. It says that consider each of the following molecules. Okay, for each, state whether it is symmetrical or non-symmetrical. Okay, 2, state whether bonds are polar or non-polar. And then 3, state whether the molecule is polar or non-polar. Okay, let's look at this molecule. What do we see? We are having a hydrogen atom attached to a chloride atom. Okay. Now, with this arrangement, let's start with the first one. Is it symmetrical or non-symmetrical? By the fact that this molecule, this makes this molecule to be non-symmetrical. So the answer is non-symmetrical. Okay. Then the bonds. Okay, we have one bond in this case. Is it polar or non-polar? The bond is polar. Now, I want you to tell you that these two factors, the molecule being non-symmetrical and the bond being polar, implies that the molecule is polar. Okay. Yes. Yeah, then we come to this molecule, carbon dioxide. Okay. How's carbon dioxide appear? It has carbon as the central atom with a double bond attached to oxygen and another double bond attached to this oxygen. Okay, we need to realize that having a double bond here and having a double bond here denies carbon to have any lone pair. The central atom, which is carbon, does not have any lone pair. Okay, so that implies that carbon molecule is linear. It is linear with these similar ends, oxygen this side and oxygen this side. That makes the molecule to be symmetrical. Okay. And then we come to the bonds. Are they polar? Yes, definitely they are. We have carbon different from oxygen. So bonds are polar. Okay, we need to know that because the molecule is symmetrical, being with polar bonds does not make it a polar. So what is going to be the molecule? The molecule is a non-polar. Okay. We need to know that if the molecule is symmetrical, it is definitely non-polar, even if it has polar bonds. Yeah, then we come to this one, hydrogen cyanide. Okay. When you analyze the bonding of this one, we are having our central atom, which is carbon. This central atom is a group 4, having 4 unpaired electrons, and all the 4 unpaired electrons are used for bonding, 3 bonding with nitrogen and 1 bonding with hydrogen. Okay. So let us now ask ourselves, is it symmetrical or non-symmetrical? Because nitrogen, this end is different from hydrogen, the other side. That makes the molecule to be non-symmetrical. Okay. Yes. Then we come to the second one. Are the bonds polar? Definitely they are. Because when you look at carbon is different from nitrogen, obviously this bond is polar. And carbon is different from hydrogen, that one makes that one polar. So yes, the bonds are polar. Okay. Then we come to the last one, the molecule. Is it polar or non-polar? Now these two factors, what are they? The molecule being non-symmetrical and the bonds being polar, it makes the molecule to be polar. So the molecule is polar to water. Water has oxygen as the central atom. But we know that oxygen belongs to group 6. So in other words, when you analyze this molecule, it has two bonding pair, one bonding with hydrogen and another one bonding with another hydrogen. Now the two lone pairs which are here are the one responsible for this shape. They push these bonds, this bonding pair close, creating what we call angular or V shape. Okay, now the question comes, is the molecule symmetrical or non-symmetrical? It is non-symmetrical. Okay. Angular is a non-symmetrical shape. Okay. Bonds, are they polar or non-polar? Now, oxygen is different from hydrogen, and this oxygen is also different from hydrogen. So that makes the bonds to be polar. So the bonds are polar. Okay. Yeah, then the molecule. Like I said before, once you have these two situations, what are they? The molecule being non-symmetrical and having polar bonds. That implies that the molecule is polar. Yeah, then comes this one, boron trichloride. In this case, you have to know that boron belongs to group 3 with 3 valence electrons, all of them which are used for bonding. So in other words, when you analyze the molecule, it will have 3 fluorine atoms spread around in a shape which you call trigonoplanar. Okay? Now the question comes, is it symmetrical? Yes. This molecule is symmetrical. Okay. Does it have polar bonds? Yes. Boron has a different electronegativity from fluorine, so the bonds are polar. Okay. Then we come to the molecule. Is it polar or non-polar? The moment you have the molecule being symmetrical, it will definitely be non-polar. So the molecule is non-polar. Okay. Yes, so we come to this molecule. It's a boron attached to 2 fluorine atoms and 1 chlorine atoms. Like we said, boron belongs to group 3 with 3 unpaired electrons or valence electrons. So the 3 are used for bonding. One bonds to F, another one bonds to F, another one bonds to chlorine. And it means that it doesn't have any lone pair. So the shape is trigonoplanar, but the symmetry is destabilized by having another molecule here. Fluorine are there, but they are different from chlorine. So the presence of this one makes the molecule to be non-symmetrical, because it's different from the fluorine atoms. So it's non-symmetrical. And the bonds, are they polar or non-polar? Definitely they are polar, because boron has a different electronegativity from fluorine. So the bonds are polar. Now, the moment you have these two, what are they? The molecule being non-symmetrical and having polar bonds implies that the molecule is polar. Yeah, so we come to this one now, NH3, which is ammonia. Okay, what do we know about ammonia? This is what we know. We know the central atom is nitrogen, belonging to group 5. So with 5 electrons distribution, so we have 1, 2, 3, 4, 5. So this means that ammonia can bond freely with 3 hydrogen using this unpaired. So we are going to have that one, we are going to have our hydrogen there, and our hydrogen here. Okay, which gives you this structure, which is N, where hydrogens are here. Okay, why the curving? Because you have a lone pair here. This lone pair forces the 3 bonding pairs to hydrogen to curve inwards. There's a repulsion between this lone pair and these bonding pairs. So this is the shape we have. It's trigonopyramidal. But the question is it symmetrical or non-symmetrical? It is non-symmetrical. Non-symmetrical. Okay. Then we come to bonds. Are they polar or non-polar? The bonds are here. It's between nitrogen and hydrogen. These are 2 different atoms having different electronegativities. So the bonds are polar. Then we come to the molecule. Now we need to know that once you have these 2 terms, or once these 2 terms are satisfied, the molecule being non-symmetrical and the bonds being polar, it means that the molecule is polar. So the molecule is polar. Into CH4, methane. For this one, the central atom is carbon, which is a group 4. So all the 4 valence electrons are unpaired, giving you 4 bonds like this. Okay. adopting a shape of tetrahedral. Now, with this shape, what can we say? First of all, you have to know that the central atom doesn't have a lone pair to push these bonds out of symmetry. So the molecule is what? Symmetrical. Okay. Okay, the molecule is symmetrical. How about the bonds? Carbon is different from hydrogen, so the bonds are polar. Okay. Now, I want us to know that once the molecule is symmetrical, definitely it will be non-polar. That one does not matter whether the bonds are polar or non-polar. So what's going to be the molecule? The molecule is non-polar. Yeah, so we come to this one, which is chloromethane. Okay. Yeah, when you look at here, the central atom is carbon. This carbon is a group 4, having 4 valence electrons. So it can form 4 bonds without a lone pair. So what are we going to have? We're having all the 4 bonds. Hydrogen, hydrogen, hydrogen. But one is a chloride, one is chlorine. Okay. So what does that mean? It means that the symmetry is not perfect. This one destabilizes the symmetry. That makes the molecule to be non-symmetrical. So the molecule is non-symmetrical. Okay. How about the bonds? The bonds are all polar. So the bonds are polar. Because carbon is different from all these atoms surrounding it. Then you come to the molecule. Yeah, you need to know that once the molecule is non-symmetrical and the bonds are polar, definitely the molecule will be polar. So the molecule is polar. Yeah, then we come to this one. Phosphorus pentachloride. Okay, what do we have here? We have a central atom with 3 links, and 1 up and 1 below. So what happens is that these 3 link up to form a triangle, and each one of the atoms making up the triangle links up with the one up and the one below. So the shape we get out of this, remember all of them are the same. The shape we get out of this, we call it a trigonal bipyramidal. It is a symmetrical shape. Okay, so what can we say? The molecule is symmetrical. Okay. Okay. How about the bonds? All the bonds are polar. Phosphorus has different electronegativity from chlorine. So, polar bonds. Now, the moment the molecule is symmetrical, it doesn't matter whether you have polar or non-polar bonds. The molecule will be non-polar. So, non-polar molecule. Yeah, then we come to this molecule where phosphorus is bonded to 4 chlorine atoms and 1 fluorine atom. Now you need to know that phosphorus belongs to group 5 or group 15. Group 5 has 5 valence electrons. And what do we see here? All the 5 valence electrons are used for bonding. So you're going to have P bonding to those 3 in the middle. You can have Cl, Cl, Cl. Then you have 1 here and 1 here. But one of them is fluorine. So this one is chlorine. Now I need to tell you that the geometry is still trigonobipyramidal, but it's not perfectly symmetrical because of presence of another atom here, which is different from the rest. So when we talk about symmetry, what are you going to say? Non-symmetrical. Because of the presence of this one. How about the bonds? The bonds are polar. Okay. How about the molecule? The moment you have a non-symmetrical molecule and you have polar bonds, definitely you're going to have what? A polar molecule. So the molecule is polar. Okay. Yes. So you come to this sulfur attached to 6 fluorine atoms. You have to know that sulfur belongs to group 6 or group 16. And sulfur is the central atom, so sulfur can bond to 6 in this way. This 4, they form in the middle and it's F, like that. Then you have 1 here and 1 there. So what will happen is that these 4 link up to form some kind of a square, and each one of the 4 in the center links up with the one up and with the one below. The molecule you obtain, the geometry you obtain out of that is octahedral, and octahedral is symmetrical. So what are you going to say? The molecule is symmetrical. So it's a symmetrical molecule. How about the bonds? The bonds are polar. Sulfur has different electronegativity from fluorine. So, polar bonds. Okay. Then the molecule. Now, the moment the molecule is symmetrical, it is non-polar, even if the bonds are polar. So what I'm going to say, the molecule is non-polar. Yeah, then we come to this molecule. So how do you approach this molecule? This is what we have. You have sulfur as our central atom. Okay? Sulfur belongs to group 6 or group 16, having 6 valence electrons. Okay, here we can see that it has used all the 6 to bond. 5 plus this one is 6. That implies that our central atom doesn't have any lone pair. So let us distribute the 5 F. 1 is here, 1 is here, 1 is there, and 1 is here. We can put 1 here. Then comes our chlorine. Now you need to know that the presence of this one chlorine, which is different from the rest, destabilizes the symmetry. So when you're asked whether the molecule is symmetrical or not, we can say it is non-symmetrical. Okay, how about the bonds? Are the bonds polar or non-polar? The bonds are polar. Why do we say that? Sulfur is different from all these surrounding atoms. So there is a difference in electronegativity. So how about the molecule? Is it polar or non-polar? Now, the moment you have a non-symmetrical molecule with polar bonds, it means that the molecule is polar. So the molecule is polar. And with that, I'd like to say thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. We urge you to subscribe, to comment, to like, to share. And we need to also to tell you that Physical Sciences Silver Bullet specializes in physical sciences, grade 12, grade 10 and 11, and natural sciences, grade 8 and 9. We recommend that when you are using our channel, please use the playlist. It's well arranged to simplify your life. Grade 8 and 9, just look for natural sciences grade 8 or natural sciences grade 9. For grade 11 and 10, click physical sciences grade 11 or physical sciences grade 10. As for grade 12, every chapter is presented independently. So just click on the chapter of your choice, and then you'll have all the material which you need for that chapter. With that, I would like to say thank you. Stay blessed. See you next time. Bye-bye.